Hello everyone. Today is the 73rd day of Leetcode 75 challenge. Let's begin with the 73rd question. Question 452. Minimum number of arrows to burst balloons. The level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the easiest way possible. So you are given a 2D integer array points. Okay, so array is given of the name points. The points I represents x start, x end, a spherical balloon taped into a flat wall in an xy plane, whose horizontal diameter stretches between x start and x end, which basically means that if this is an xy plane, right, and suppose this is a wall in back of it, okay, so balloons are taped right like this. So by understanding, so that they don't fly away, right, they are just taped like this. There could be this way also, right, something like that. And this x start x end, which is given into our points array, represents their diameter. Okay, suppose if it is 0, it is 1 and 2. Then if it is 3, this is 4. So this 1 and 2 is the diameter of this particular balloon. This 3 and 4 is the diameter of this particular balloon. Let's take this as 6 and 7. So uh, this is the diameter of 6 and 7, right? Ignore the drawing, just take it as this way only, right? So this balloon is of this diameter, right? So this is what they are given to us. Now you do not know the exact y coordinates of the balloons. You only know their x range, which means that a balloon can be this way also in top of one another, right? It can be in any direction here also, right? But what we know that in the x-axis where it is placed, right? An arrow can be shot vertically upwards positively in y direction only from any point x on the x-axis. A balloon is burst by an arrow shot at x if and only if x start and x end. Okay, so basically what they're trying to say that if I shot a balloon from here, it will only burst this balloon if and only if the range of the balloon is between the range of this diameter. Suppose if the balloon diameter is 1 comma 2, right? So I will shot the balloon arrow in that range. It has to be between 1 and 2, right? Visually if you can see, if I have to shot this balloon, I have to shot the arrow from here. So it is between 1 and 2, right, where 1 and 2 are inclusive. A single arrow continues infinitely upwards, bursting all the balloons in its path. So what does this line means that if there are more balloons in the same path, right? If you can see, this balloon is somewhat in between along with this balloon, right? So if I sort this arrow, so it can sort this balloon also, right? So two balloons were sorted in one arrow. Multiple balloons overlap in their x ranges. They can all be burst with one arrow shot at their common overlapping point. This is what we saw. If they're overlapping balloons, they could be shot with a single arrow. Your task is to return the minimum number of arrows required to burst all the balloons. Fine. I hope you understood the problems now. And at the end, you have to return the number of minimum arrows required to sort all the balloons. Now let's look at the constraints. The points length will be from 1 to 10 to the power 5, and points phi, the range of will be of course of two size only. And x start and x end value would be from negative 2 to the power 31 to positive 2 to the power 31 minus 1. Okay. So I hope you understood the problem explanation and the constraints. Now let's move to the next slide. Now let's understand the input output explanation. So if I take this, right, and this, so the maximum value 1 to 6, right? 1 to 6 to 8, 7 to 12, 10 to 16. Done. So these are the balloons, right? I have drawn this balloon's diameter here. Now suppose output is 2, right? Let's see how. If I shot one arrow from here, and this arrow's range is between 2 comma 8, it is between 2 comma 8 if you can see, and also it is between 1 comma 6, right? So it will come and it will burst these two balloons in one shot. Done. After that, we are left with this balloon, right? If I use another arrow and the range is between 7 and 12 and 10 and 16, right? It will burst these two balloons also in one go, right? So in total, we only require two balloons, right? If we have burst balloons in this way, suppose I have taken this particular range to burst, right? then in that case, to burst this balloon will require another arrow, right? 3 arrows. So that is inefficient. So from here we have observed that we have to take a common ground to burst the balloons. Okay, let's take this example 2 here. If you can see, for to burst this balloon we required one arrow, right? And this arrow cannot burst any other balloons because they are not overlapping. If you can see, 1 and 2 is complete diameter, 3 and 4 is the another diameter, right? So another arrow will be required. Similarly, 5 and 6 is another independent balloon, we can call it that way. 7 and 8 is also another independent balloon, right? That is why the total number of arrows required will be 4, right? If there is another example, suppose let's take 1 2 2 to 3, right? Here, in this case, what will happen? One balloon shot at the range 2 will burst these two balloons, right? In using one arrow itself. Fine. So I hope you understood the input output explanation. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. And let's start by understanding the goal first. So we are given a list of intervals, each represented as x start and x end, right? So this is the interval given to us, and this represents x start and x end. Simple. Each interval corresponds to a balloon horizontal diameter on the x-axis. So this gives the diameter of the balloon in the x-axis, and we can shoot an arrow vertically at some point x. An arrow bursts all balloons that covers this x, that is x start to x end. As we saw that we will take a point x and we will short the array. And number of balloons which are coming into that point will get burst. If two balloons overlap, a single arrow shot in the overlapping region can burst the balloon, both balloons, right? The goal is to minimize the number of arrows needed to burst all the balloons. So, suppose, as we understood, if this is the case, right, and if I use one arrow from here, it will burst this balloon also, this balloon, and this balloon, right? If we don't use the arrow efficiently, we will be requiring 2 to 3 balloons, arrows to burst these balloons, right? So that is what we have to look for. And the brute force approach would be try every possible x coordinate or simulate shooting arrows at many positions, which would be inefficient. Basically, in layman terms, so if there are multiple balloons, we will try sorting for each number. Suppose if there are 1 2 3 4 5, so for each range x value we will sort the arrows, right? And we will try to see that in which particular range the number of arrows required is less, right? So this will be a very efficient solution, right? So let's look for the efficient one. Now let's visualize the process. Now before going to this part, I will try to point out one more thing here. What we have observed till now is that they have talked about xy plane, right? Then they talked about overlapping sequences, right? And they also give us the diameter, right? Like x comma y. And they said that there could be another x1 comma y1 which might overlap, right? Basically this thing only. So from here we can boil this thing down to a kind of an interval situation. Why? Because in interval what happens? We try to look for the common intervals, and the intervals which are overlapping we try to make them one, right? And we burst or we use that interval. Suppose if interval is 1 comma 3 and another interval is 2 comma 5, so if I try to, so these are overlapping, right? So if I make it 1 comma 5, this becomes one interval, right? That means these two intervals were taken down to make one interval. Fine. So from here we can boil down this question to an interval based question, right? So let's, so one thing is clear to us, this is an interval based question, so let's move ahead with that. So now let's take this example to understand the intuition, right? So let's first and foremost thing which I will be doing is doing the sorting. Now why sorting? Let's understand that. If you can see here, these are the values given to us, right? Now let's take this as a number line, right? Fine. One starts from here and it ends at 13, x-axis. Okay. 1 comma 3 will be placed here in the number line in 1 comma 3. Definitely. 9 comma 12. It is given in the second order, but it won't be placed in the second order in the number line, right? It will be placed where the 9 starts and the 12 ends. Definitely. Now 2 comma 6. It is given after 9 comma 12. That does not mean that I will place it after 9 comma 12, right? In the number line. in the x-axis. We could call it x-axis also. I will place it in the where it belongs, right? In the 2, which comes after 1, and 6, which comes after 3, 4 or 5, right? So again, 4, 5 is placed in the number line, depicting on the number line where it is has to be actually. Fine. 10 comma 12. So 10 is here and 12 is here itself, right? 7 comma 8. 7 is here and 8 is here. 11 comma 13. 11 is here and 13 is here, right? And if you can see at the end, this all the intervals I will say, or the diameters which are given to us, has been sorted unknowingly, because 1 comma 3, then comes the 2 comma 6, then comes 4 comma 5, right? 1 comma 3 comes, then 2 comma 6 comes, then 4 comma 5 comes, then comes the 7 comma 8, right? Then comes 9 comma 12, right? So indirectly they are all sorted, right? So if I do the sorting of these numbers, I will get a perfect range as this, right? Which will make our problem much more easier to be solved, right? So this is the one thing which I will be doing. Let me sort this and write it again. Okay, so this is a sorted array, and this has been sorted on the basis of the start time, or the start x, on the basis of start x. If you can see 1 2 4, then 7, then 9, then 10, then 11, right? Because this will make the work much more easier to understand when the diameter gets end, right? You will understand how, right? Okay, now let's look at the example here. Okay, let's focus here. I have an arrow with me, right? At least one arrow is required to burst one balloon. That is clear to us. So from here, if I sort this arrow, it will go and it will burst how many? It will burst this 2 comma 6 and 1 comma 3 diameter based balloon, right? Great. Now let's take another. Now since 1 comma 3 and 2 comma 6 balloons are used up or burst, I will require another arrow between 4 and 5 to burst this balloon, right? Fine. And to burst the 7 comma 8, I will require another independent arrow, right? Done. Now to burst these three balloons, what I will do, I will put it between 11 and 12 here. So it will go and burst this balloon, correct? So what you have observed here, if you can see, 2 comma 3, 4 comma 5, 7 comma 8, 11 comma 12. Let me write it somewhere. 2 comma 3, 4 comma 5, 7 comma 8, then it's 11 comma 12. In 2 comma 3 and 11 comma 12, what you can observe is that you're taking a common point here, right? This one and this one, right? Then in 11 comma 12, you are taking a common point. If you can see this point, right? And in 4 comma 5 and 7 comma 8, these are individual balloons, right? Here you don't have any common points. You have to burst this balloon, and for this balloon you will be requiring one arrow, right? At least one arrow will be required to burst this balloon, right? So there is no common point here. I hope you got this intuition, right? So here this happened because of the common section, right? I will write it as, this is the common common point, right? And this is their individual, right? So IND. Second thing to be observed here is that if the current end, suppose you're standing at 1 comma 3, right? So the current end value is what? It's 3, or I could say, yeah, that's good. Next end, next start, which is 2 comma 6, right? Next start value is 2. What you observed here, if current end, if it is greater than or equals to the next start, overlapping is 100% there. Fine. Take any case. Take let's take this. We took this case, right? Take another case. Let's take this 9 comma 12 with 11 comma 13, right? So for 9 comma 12, ending is what? 12, right? And for the 11 comma 13, next start is what? 11, right? So we can see that 12 is greater than 11, right? According to this scenario. So they are overlapping. We can see visually here they are overlapping, right? So when they're, this is the case when they're overlapping, right? So what I will do, so this case means if current end, if it is greater than or equals to the next start, that means they're overlapping. Fine. Now from here what we can derive is that in 1 comma 3 there is 1 comma 3, right? And there is 2 comma 6. We clearly observe 2 comma 3 is the common point between both the balloons. And if an arrow is shot between this inclusive of 2 comma 3, both the balloons will be shot, right? Then you figure out that the second case is that when we know that it is overlapping situation. So here, since it is overlapping, right? So according to our this condition, what will happen? 3 is greater than equals to 2. That means overlapped. Now we have to know the range, right? At what range I should sort the balloon that it overlaps both of them. So that range, how we will get? If I do maximum of the current start, which is, let's take 1, right? And let me write it as CS, current start, and the next start, right? And this could be interchanged also. You could, if you're standing here, suppose this could be your current start and this could be your previous start. It could be interchanged, right? So if you do this, the current start is what? Current start is 1 and next start is 2, right? So maximum from this is 2, right? Fine. Then minimum of current end comma next end. So next it's I guess current is 3 and next is 6, right? So minimum is 3. So what we got, start as 2 and as 3 as the common range, right? And this common range can be carried forward to check whether the third balloon also comes under this range or not, right? So this is the third thing which you figure out. So this, the common ground which we get when carried forward for the next interval, it's also like, let's take this example here, 9 comma 12, right? 9 comma 12 compared with 10 comma 12. Fine. So if I take the maximum of this, it's 10 definitely. Minimum 12 12, it will be 12. Fine. That means that if I shot a arrow at 10 comma 12 within this range, this two will get burst. Visually we can see that, right? But before bursting, what I will do, I will try to check for the next interval, 11 comma 13, and I will compare this with this interval. The maximum of this is what? 11, right? A minimum is 12. 11 comma 12 using this third formula, right? Max and min. Now I got 11 comma 12. Still till now I have used only one arrow, right? After that I don't know what will happen. But here, if I can see, if I burst, if I throw an arrow or shot an arrow at this 11 comma 12 range, this will definitely burst these three balloons, right? That is why we have to carry this forward, this common ground. So I hope you understood this part. Now the final point, here I will directly write if current end, if it is less than next start, no overlapping. No overlapping means we need one arrow here. Okay. If you can see the case of 4 comma 5 with 7 comma 8, right? Suppose that 1 comma 3 and 2 comma 6 diameter balloons are burst already. Suppose this is done already. So we are in this now. So we can see that 5 is less than 7, right? And when the ending point is already smaller than the starting point of the next interval, they are never going to overlap. That is the another reason why we sort this particular given intervals or the diameters, right? That is pretty clear to us. So in that case, we will always increase the arrow size, arrows numbers by doing arrow plus plus, and we will move ahead the next interval here. Fine. So these are the four scenarios: current and if it is less than next start. Okay. This next start can be also replaced by previous also. That is upon you which one you take as the current. Fine. So it depends on you which you take as the previous. If you can replace this with previous also, so then the this if else condition will be changed a little bit because it will be comparing with previous with the current, right? So I hope you understood this complete intuition or the visualization process of our problem. The third step is how we can simulate this, right? We will sort the balloon, right? We will take the previous points, first balloon range. Now why we are taking in this previous variable, what we will do, we will store the points zeroth index value. Suppose if it is in this case it was 1 comma 2, right? Why we did this? Because it was 1 comma 3. So we'll throw shave 1 comma 3 initially, and this will become our previous. and we will start our arrow iteration from the next or the 1th index. In that case, what will happen if previous end, if it is greater than or equals to the current start, this got changed a little bit, right? This condition got a change little bit now. It's the same thing, just the variable are different, so it got changed. Another will be if previous end, if it is less than the current start. So we can see this point 4 also got changed a little bit, right? I hope you have understood this particular thing. Now we will have the count one, at least one arrow is needed. We'll iterate through the each balloon, right? And if we find that if current start, if it is greater than the previous end, this condition, there is no overlap. That is why we require a new arrow for it, and we will update the range, because suppose if this suppose these are four ranges, right? And these three are already getting overlapped, and you have some values xy with you, but you saw that this and this are not getting overlapped. That means that this particular thing is done. Now this is a new range, so we take this range and update it. Got it? Else we overlap, right? Then we take the we can take the previous maximum of previous and current start. This is the same thing which we did, and we did this return count at the end. Now what we figure out, sorting NCS balloons are checked in correct order for overlap. Greedily shrinking the overlapping region allows us to reuse arrows for as many balloons as possible, basically doing the minimum and maximum. Each balloon is visited once after sorting, making the approach efficient. If you can see, we are just visiting the array balloon only once, right? Not multiple times. So I hope you understood the intuition explanation. Now let's move to the next slide. Now since we got the intuition of the problem, let's look into the approach, how we're gonna solve it. Step 1, handle a base case. If n is 0, just return 0. There is nothing to be done. No balloons, no arrows needed. Step 2, sort the balloons, initialize the tracking. We sort the balloons, we declare variables count 1 and previous points. Previous will store the index 0 value so that we can use it as a previous interval. Why? After sorting, checking overlap reduces to comparing each balloon with the previous one. And we also know why we did the sorting, right? We got two reasons for sorting. First, in number line, all the ranges get sorted indirectly. Second, if the current end is less than the next start, that means they are not overlapping. Suppose if it was 1 comma 3, then it's 4 comma 5. They are never going to overlap because we already sorted the values. Now why? Previous helps detect overlaps and count records arrow used. Now at step 3, single pass to resolve the overlaps. So if you can see, this is the for loop we will be doing. We will start from 1 and go to end. If this point, this is basically current start, if it is greater than the previous, right, previous start, that means we need another arrow and we will update the position. Got it? Otherwise we will take the current start and previous start maximum and minimum of the current values. Got it? Here if no overlap, we need a new arrow, update the previous, right? And finally, after coming out of this for loop, we will just return the count of the arrows. That's it. So I hope you understood the approach explanation. Now let's move to the next slide. The code is the exact copy of the approach discussed. Let's understand it line by line. This is a base case, right? If n is 0, return 0, no need to do, nothing to do. We print or we sort the array, points array. We store the points 0th index values into the previous and initialize count with 1. Now this is the for loop. From the points, we take out the current start and current end. And from the previous, which we stored here, right? Since we are starting from 1, we will take out the previous start and previous end. Now this makes us to easier to read and do the maths, right? So we can find, okay, current start, if it is greater than the previous, increase and update. Otherwise, take the max min and move ahead. That's it, right? And for this, the time complexity is n log n. Why? Actually, to be more precise, it is n log n plus n. This n log n comes from this sorting, right? And this n comes from this particular for loop. Now, since n log n is already a bigger value than n, so we sometimes neglect this n and take this as the time complexity. Fine. And space complexity is O of 1 because we are not using any kind of array or data structure to store the values. We're just using the count to store the points and return it. Okay, so I hope you understood the code explanation. Now let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of the example. I've also brought down the code here for our better understanding. Let's begin. Okay, so first thing is what? We sort the points array. So we'll sort this. So after sorting, how it will look like? Okay, so this is the array after sorting. Now in previous, we will store what? Points 0, this one, right? So previous has this now. Fine. Also count. Count is having 1. Arrows basically. This is arrows. Now we will come to the for loop, and let me, instead of writing current start, I will just write CS CE, PS for the previous start and PE for the previous end. Fine. Now, so we are standing here now, right? Loop starts from the 1. So current start is what? 2, and end is this. Previous is what? 1 and 6. Correct. So now we will check if current start is greater than previous end. What is current start? Current start is 2. Previous end. What is previous end? It's 6, right? So no, false. So we come to the next else condition here. And in previous, we store the maximum of current start and previous start. So current start is this and previous start is this. What is the maximum? It's 2, right? So what we will do? This will become 2 and minimum of this. So this will become 6. So our new previous becomes, basically I will update it here. It becomes 2 comma 6. And if you want to visualize this thing, how it's a common ground, let's take this 1 to 6, then 2 to 8, right? If a arrow is short, it should be in between this 2 comma 6. Got it? Now let's move ahead. Now we are standing at this particular range. So what we will see, we will update this current start and current end here. So this will become 7 comma 12, right? Great. Now we'll check for this condition. Current start 7 greater than previous end, which is 6, right? So this condition becomes true, right? So that means they are not overlapping. So what will happen? We'll increase the count to 2. Previous points will get updated. So this will basically get updated with 7 comma 12. Fine. And then we will move ahead to this part. Now again we come back, we update this current start. Current start is now 10 and current end is now 16. Correct? We check for this condition. What is the current start? It's 10, right? Is it greater than the previous end, which is 12? No, right? It's false. So what will happen? We will take the maximum of current start and previous start. Current start is 10, previous start is 7, right? So maximum will be 10. Current end and previous end minimum, right? So it's 16 comma 12. So it will be 12 itself because it is a minimum. So our previous updates to 10 comma 12. And if I draw the lines, let it be 7, 12 and 10 to 16, right? So this is where a person should short the arrow to, so that both the balloons can burst 10 comma 12, right? And after that, the loop is done. We come out of the loop and return the count, which is 2. And our output is also 2, right? So I hope you understood this dry run. And if you have any doubts or confusion about the solution we arrived at, how we arrived at it, I would suggest going back and understanding the intuition, the approach, and the code. And after that, do a dry run by yourself on 2, 3 examples. And I'm pretty sure you will understand both the solution and the thought process behind it. Now let's move to the next slide. Now, since we are familiar with the problem and the solution, let's move to the lead code and code the solution. Let's start our coding. First, we will have the n, length of the points, right? After that, if n is equals to 0, just return 0, no arrows required. Then we will sort the points list, have previous with the points 0, and arrows will be 1. Okay. For I in range, we will start from 1 and go up till n, right? We will have current start equals to what? Points of I 0, right? Current end will be points of I 1. Then there will be previous start, which is basically from previous 0, previous end, which is basically previous of 1, right? Then we will check if the current start, if current start, if it is greater than the previous end, that means that there is no overlapping. So we will just increase the arrows count and update the previous with points of I. Else, previous of 0 will get the maximum of, let me copy, uh, current start and previous start, right? And this will become, previous one will become basically current end and previous end, correct? And at the end we'll return the arrows. This has to be minimum. Let's try submitting for the sample test cases. Now let's finally submit our solution. So we have successfully submitted our solution. Now code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.